Hello everyone, welcome to another lecture of School of Solana. Today we'll be talking about the introduction into the Rust programming language. Before we begin, let's talk a little bit about the content of this lecture. We'll be talking about the introduction to Rust. We'll not be talking about Solana concepts today yet, that's for a lecture for the next week. And we'll be doing some of the hands-on examples to get our hands dirty and introduce ourselves into how Rust programming works. Before we do any coding, let's just briefly talk about Rust history, how kind of Rust came out to be one of the most favorite programming languages currently in the software development ecosystem. Rust is a modern systems programming language. It prioritizes safety, speed, and concurrency. It is statically and strongly typed programming language, and it was founded as a personal project of Graydon Hoare in 2006. In 2009, it was sponsored by Mozilla Foundation and later quote-unquote acquired by Mozilla, and it is maintained by Mozilla to this day. It supports WASM or WebAssembly. It has a lot of popularity in systems programming, game engine development, and obviously into the blockchain ecosystem, starting with Solana and a lot of the new L1, a lot of the new layer 1 blockchains kind of popping up right now, like Aptos or Sui, that also supports Rust as their main as their main or as their programming language for developing programs there. The very first release of Rust came to be in 2015, and it saw a rapid growth in the point that it established its own foundation in 2021, which is only 6 years after the first release. And it became a most loved language since 2016, and Rust popularity only grows year by year. There are many companies using Rust right now, and a lot of the popular applications are written by Rust. But for us, obviously, it's Solana, but you can find different like Cloudflare or 1Password that are those where fundamentals are already built on Rust programming language. That's up for the introduction, and let's jump right in and talk about the basics of it all, and that's obviously a Hello World program. So as you can already tell, Hello World program in Rust is very similar to Hello World in pretty much any other language. So we are essentially defining our main function using an fn keyword, and in that function we are printing out the line with Hello World string. So you can just go right ahead and copy it into your development environment. However, if you have not yet set up your development environment, you can use something called Rust Playground. I will just demo a Rust Playground for now. So essentially, you can just copy different Rust snippets and execute them directly in your browser. So we have our Hello World demo already in the playground, and we can just run it and see the output directly into the browser. So if you have not yet set up your development environment, go ahead and use Rust Playground, but you can just go ahead and use whatever tools you need to execute the snippets that we'll be demonstrating today. In this slide, we can see that we can define variables in Rust using a let keyword. Keep in mind that Rust is statically typed language, and that means that compiler needs to know what type are the variables at the compile time. But however, in this slide we can see that we are not explicitly defining what types are those different variables. This is because Rust has something that is called inference engine, and it's pretty smart. It does more than just looking at the type of the value expression during the initialization, but it also looks how the variable is used afterwards in the program. So that means that we can essentially define variables without specifying the data type. Let might seem really familiar to a lot of you JavaScript developers, but it's definitely not the same thing in Rust. In JavaScript and many other languages, variables created with let are mutable by default. That means we can initialize it with some value and then essentially change or reinitialize that value to a different one. This is, however, not the case in Rust. So if we take, for example, this piece of code where I'm defining a variable called name and I'm assigning or initializing with the value Andre, and at the next line we're trying to change that value of that particular variable, this would be completely fine in JavaScript. However, if I try to run it in Rust, we will end up with an error that says we cannot assign twice to immutable variable name. This means that in Rust, all variables created using let keyword are immutable by default. That means you cannot reassign their value once they've already been assigned. However, if I create a variable and I will not assign it, that means I will assign it in the next line. This will still be fine in Rust. We are not mutating it. We are just assigning or initializing with the value. So let's just say if we want to, if we get to the previous example and we want to create or make our variable mutable, we'll be doing that by adding a mut keyword, which is short for mutable. And if we add keyword mutable to our variable name, we are then free to reassign the value. So if I run it again, this will compile just fine. So if we take a look at this next slide, we can see that we can obviously manually specify the data types of the variable when defining it. All of the standard variables types that we know from other programming languages are available at our disposal. So that means we can use assigned and unsigned integer, floating point types, booleans, characters, and strings. But we'll be talking specifically about strings a little bit later. So let's talk about strings in Rust. Strings in Rust aren't as simple as strings in JavaScript. For example, in JavaScript, both arrays and strings, where strings are pretty much just an array of characters, are mutable and ever-growing. So all of us are kind of used to keep on pushing to a string or array in JavaScript, mutating its length, and it works just fine. This is because strings in JavaScript are heap allocated and they don't have a fixed length. This is, however, a little bit different in Rust. So if we take this example, where we are creating a mutable list with a length of 3, and then we try to reassign it to a list with a different length, essentially trying to mutate the list's length, this will fail. This is because arrays in Rust are stack allocated and with fixed length. This doesn't mean that you can't have a collection in Rust, which you can grow and shrink with time as much as you want. It's a completely different data type that we are calling vector. So this also tells us that there will be two different underlying types of strings in Rust. There are two. So str, which is essentially a string slice, similar to an array. It is fixed length and it is immutable. On the other hand, we have a string. A string is stored as a vector and it is used to store UTF-8 data with not a fixed length. So if we, for example, take our first example and we are using a data type called str, we can initialize it with some value. However, we'll be unable to mutate its length at the later stage in the program. So we are essentially tied down to this value. So this is typically what we don't want. We want to have a little bit more fun with strings, kind of resizing the data structure and do whatever we are used to with doing with strings in different programming languages. And this is where string or data type called string come to a help. So here you can see an example where I'm creating a mutable variable called name, and we are creating a string from some sort of characters, which in this case is OND. And then we can, for example, manipulate it as we are used to in different programming languages. So I'm pushing more characters into the predefined string. So if I run this one, it will work completely fine, and you can see that our two substrings are combined now into one string. So yeah, our first example with the str data type, they are essentially string slice, and they are similar to array in Rust. They are fixed length and unmutable. The second one is a string object. This one is stored in a vector, and it is used to store the UTF-8 data with not a fixed length and a little bit more freedom to work with working with it as much as we are kind of used to from different programming languages. So let's sum up what we have learned about data types and variables in Rust. So even though Rust is statically typed language, and that means compiler needs to know what types are the variables at the compile time, we can create variables without specifying its type and let the inference engine do its work. If we want to specify the type, we can do it with the specification right after we name our variable. However, in terms of naming our variable, there are a few rules we have to follow. Letters, digits, and underscore characters are available for us to name our variables. Variables have to begin with either a letter or an underscore, and this is really important. Upper and lowercase letters are distinct in terms of naming our variable. And the key thing is that by default, variables are immutable, which means if we want to reassign or change the value of our variable, we have to make our variable mutable by adding an mut keyword. So let's talk a bit about functions in Rust. Functions in Rust are defined using an fn keyword and with curly brackets. So pretty much the structure is very similar to other programming languages. We define using an fn keyword, naming our function, and then selecting the input parameters that our function should have. So in terms of, we have already kind of defined our first function before in our Hello World program, where we created a main function in every program, which is the main entry point. But in this particular example, we can see that our main function is calling a different function called fn hello. And fn hello then prints out hello from function fn hello. So this is a really basic example how we can call different functions in Rust. If we want to talk about return types, we have two different syntaxes that we can use. The first syntax is obviously specifying the return type with an arrow and then returning it using a return keyword. However, there is some nice syntactic sugar in Rust where we don't even have to use a return keyword to return our value. We can totally skip the return keyword, and the result of the last expression in the function body will be returned automatically. Or essentially, the last result with no semicolon means that the value is automatically returned. So let's take a look at our sample here. We have our main function where we are calling our sum function, which is essentially just summing the two x and y numbers that are in our function parameters, and are returning an unsigned 64-bit integer. So yeah, if we try to execute it, you can see that we have our result value. So we are essentially defining a new variable called result, which will take the return value of our sum function. We can see here that we are not even using our return keyword. We're just essentially doing x plus y without no semicolon. This will automatically return our value. and then we are printing out the result from our variable. So let's briefly introduce a flow control and loops in Rust. So just like any other programming language, Rust too has conditionals. So both if else, or else statements are pretty much identical to how they work in JavaScript, with two subtle differences. If statements in Rust don't need expression to be wrapped into parentheses, and Rust will not cast expressions to booleans for you like JavaScript does. But if we look at a really simple sample here, let's just do this simple if condition where we are checking the value of our variable. So for example, here we can see our if statement combined with some logic operators. Those are obviously also available to us in Rust. So you can see that the structure of our if statement is pretty much similar to the one in JavaScript. And this one is completely valid and will execute just fine. So you can see that in terms of conditionals, you can carry a lot of the knowledge from a different programming language like JavaScript or pretty much any other programming language. If we're talking about loops, Rust obviously has loops too. There are a few types of them, and let's just introduce them briefly one by one. So the most basic one is essentially defining a loop using a keyword loop. So if we do something like this, we essentially create a loop that is equal to while true in JavaScript. It is essentially just a simple loop that will be running into infinity until some condition is met, and we will manually break our loop using a break keyword. So this is, again, something very similar to other programming languages. If we want to use a different type of loop, we can, for example, use a while loop in Rust, something that we are familiar with from different programming environments. So if we do something like a while loop where we are essentially adding a condition to our loop, so the while loop is running until this condition is met. So in this particular case, until the counter is less or equal to 10, our loop will execute. So if we run it, we'll essentially get hello 10 times. So yeah, that's pretty much a while loop. And other really cool loop that we can use in Rust is for in loop. For in loop will essentially let us loop through, for example, different elements in array. So in this example, we can see that we are looping through our array of strs. So my name is Andre, and it will run through all of these elements and print them out line by line. So as you can see, in terms of flow control and loops, you can carry a lot of the knowledge that you already have. There is a bit of a syntactic difference, but essentially the basis of flow control and loops are pretty much the same in Rust. If we want to shorten, for example, our if statements, we can do it by creating an inline if statement. So this one is totally fine in Rust too. So we can create a condition variable, and then we can essentially wrap our if statement into a variable. So let's define a variable called number that will be assigned or the value of this number variable will be assigned according to this if statement. So if the condition is true, the value of our number will be 6, else the value will be 5, else the value will be 6. So yeah, that is totally fine in Rust too. So let's talk briefly about memory management in Rust. When you write your code in JavaScript, you never worry about allocating and deallocating memory. Actually, most of the JavaScript developers don't even know how to manage memory properly. Memory is automatically allocated under the hood when it's required by the runtime environment. And the JavaScript runtime engine usually is using something that we call garbage collection. So I believe that most of you are already familiar with the garbage collection, but Essentially, garbage collection is a hidden code in your runtime that is constantly keeping track of the values in your program and checking if there are any references to them. When it sees that something is no longer referred to and it is marked as unnecessary, it decides to deallocate it and free it from the memory. You can immediately tell that having something like this running during runtime constantly comes at the performance cost. But not only as a performance cost, also as a security concern, because garbage collectors can sometimes screw up and it will result in memory leaks. So Rust does not have a garbage collector, and you are probably panicking right now because you're familiar that C or C++ require a programmer to manually allocate and deallocate memory. And if you're not skilled enough, it can be a really big security concern, and it is really hard to master a proper memory management. So that's where borrow checker comes in. Even though that the Rust is not using a garbage collector, when you're writing in Rust, you don't need to manually allocate or deallocate the memory. It's already taken care of you by the compiler. The Rust compiler automatically inserts allocation and deallocation calls in the right places in your code. And it can do it because you have to follow strict rules about how you write your Rust code. And if you don't, it will just not compile. So it may be hard at first, but when you get the hang of it, out of the nowhere, you're writing high performance and secure programs. So let's learn about borrow checking and ownership to kind of understand how memory management in Rust works. So now let's talk about borrow checker. And this is what enables Rust to automatically insert memory allocation and deallocation in our code when it is compiled. So to do this, the borrow checker requires us to follow the simple concept of ownership. It might be hard to understand at first, but when you get the hang of it, it is pretty easy and it will help you write a secure and high-performing code. So we have prepared this simple test how we can demonstrate the ownership in just a brief snippet. So for example, we have a main function where we're defining a test variable. It is essentially string from this characters, which is a testing. And then we passing our variable into the owner1, and owner1 function will print out our variable. So if we run this, everything should work out fine. So you can see that the owner1 print out the string that we wanted. But what if we do this thing? So we ask owner1 to print out the string, and we will ask owner2 function to essentially do the same thing. And this is where we run into some issues. And why is that? It is because one simple rule that we have to follow in Rust, and that is every value in Rust must have a single owner. And to kind of demonstrate the ownership, when we initialize the variable test, the string value testing is owned by our test variable. Then on the next line, we are passing our variable to owner1 function. And by doing that, we move our variable to owner1. And at this point, this variable is no longer owned by our main function, and it is owned by owner1. This is what we call a transferring of the ownership. So the value is only owned by one owner, and the owner is responsible for deallocating the memory, and that's where it deallocates it when the owner goes out of the scope. So essentially, the owner is the error is telling us that we no longer have access to our variable because we already moved it to a different owner, and it's just essentially stuck there, and we cannot work with our variable anymore. So how can we solve this? We have two different ways of solving this, and the first one is by passing the immutable references. So we can create immutable references very easily, and that is essentially just by adding an ampersand before our data type, which is now saying it is a reference to a string variable. And if we are expecting a reference, we obviously have to hand over a reference, not the variable. So we'll be handing out the reference to our test variable. So by doing this, it should essentially fix our problem in this particular case. So yeah, as you can see, right now the owner1 and owner2 print out the string. So by passing the references, we are essentially bending the rule that I mentioned before, that every value in Rust must have a single owner. We are kind of bending it into a fact that a value can have any number of immutable or mutable references to it. So, but by passing an immutable reference, it automatically tells us that we cannot change the variable from the immutable reference. So what if we want to change the value of our reference? We can do that by passing mutable references. So I have prepared a different snippet of code to kind of demonstrate this. We have a simple main function, and this main function has a mutable variable called greetings that is kind of constructing hi, my name is from this characters into a string. Then we want to mutate it. The mutation will happen in a different function that is called mutate. The mutate will push string Andre into the greetings. So essentially in the end, it should print out, hi, my name is Andre. So you can immediately tell that we are again using ampersands to mention that we are passing a reference and adding an MUT as a mutable reference. A big warning here that if we are passing a mutable reference, we have to create a mutable reference to a mutable variable in the first place, because if the variable is immutable and cannot be changed, a mutable reference would be just completely meaningless. So if we try to run this code, everything should work out just fine. Yeah, so you see that we have, hi, my name is Andre. To kind of expand a little bit on this, let's just add a second mutate function and push another string, just some exclamation marks. And we can run both of these mutation strings and we should be all good. And as you can see, we have passed the mutable reference to two different functions without passing the ownership. We have added a string in both of these functions, and at the end we still had access to our greeting strings. So this is just a simple demo how ownership, which is the basis for borrow checker, works in Rust. So what have we learned about the ownership rules and memory management in Rust? Each value in Rust has a variable that's called its owner. Every value in Rust has a single owner. And when the owner goes out of scope, the value will be dropped and essentially marked as inactive and deleted from the memory. If we want to pass our values, we can do it by using references. These references can be immutable or mutable, and the value can have any number of references to it. If we'll be passing an immutable reference, please make sure that we are passing a mutable reference to a mutable variable or a mutable value. So let's briefly touch on slices in Rust. So an array in Rust is a collection of objects of the same type, and we are defining it using brackets. We are specifying the data type and their length, and the length of the array is always known at the compile time. Slices, on the other hand, are similar to arrays, but their length is not known at the compile time. Instead, a slice is kind of a two-word object where the first word is a pointer to our array that we are slicing, and the second word is the length of the slice. A great example of previous explanation is the str type that we did in the string section, because we're calling str a string slice as it is exactly what it represents. It's essentially a pointer to some memory that is including a valid UTF-8 data. Hence why string slice is not growable or mutable in any way, because it is baked in the binary itself. So yeah, and slices are obviously not reserved for strings only. We will probably use them mostly on vectors or array. So to demonstrate this, let's borrow an example from the Rust documentation. So as we can see in the main function, we are defining our array of numbers, and we can work with this array as we are kind of used to in JavaScript. So for example, we can print out values at the different indexes. So essentially just indexing starts at the 0, that's pretty much classic, and we can print out any of the values in the array. And for example, we can also print out a count of the elements or the array length, so we can just do some of these very familiar operations on the array in Rust too. However, we can also borrow the array automatically as a slice, and to do so, we just specify a pointer to our array and then specify the length of the slice that we want to do. And we have this analyze slice function to kind of perform all of the operations we're kind of used to on doing on the standard array. We can also do it as a slice, but we are obviously working only with the borrowed data. So if we run this example, you can see that we did some of these array operations on the whole array, then we borrowed the array as a slice and did the same operation only on the element that we borrowed using the slice. So let's briefly touch on how we can create structures in Rust. There are three types of structures, or also shortly called structs, that we can create using the struct keyword. So as you can see, we are using struct keyword to create a new structure. We set the name of the structure and using the curly brackets to set up the fields of the structure. This is pretty similar to how we define functions and everything else in the Rust. So about the three different types of structures. There are tuple structs, which essentially are just named tuples or pairs of two values. A classic C structs that we are seeing on the screen right now. So we're essentially can create different fields with different data types for the structure, and also unit structs, which are fieldless but are useful for generics. So let's just demonstrate it real quick. So in this code, we can see how we define a unit structure. As you can see, they are fieldless. A tuple struct is essentially a pair. So here is a pair of integer and float. And then we have a struct or C-like structure with fields. So in our main function, we can see that we are creating a new variable of a point, which is our structure, and we are setting up the coordinates x and y to different values. After we instantiate the point, we can just easily work with its fields. So here we can see it demonstrated in the print line. We are printing out the coordinates x and y from our point that we have previously created. So as you can see, you are essentially creating structs very similarly to any other programming languages that do enable us to create structures. So next, just briefly touch on enumerators or enums. Enums are essentially, we are defining them using an enum keyword, and this allows us a creation of a type which may have one of few different variants. So this is essentially demonstrations of direction, and we can see that our different variants are up, down, left, and right. It's also worth pointing out that any variant which is valid as a struct is also valid as an enum. So this was just a brief introduction to enums and structs in Rust, and as you can see, if you know how to handle these from any different programming languages, they easily carry to Rust also. Thank you for attending today's lecture, and now I will hand it over to my colleague to give you details about our next assignment.
Hello everyone. So now that you have learned how to use Rust and the basics of Rust, we have prepared next task for you. You will have to finish an implementation of a calculator. So it is a simple calculator written in Rust. Again, the repository will be on GitHub Classroom, so we will share the link after this lesson on Discord. And you will also learn something new. You will learn about traits. So it's basically an equivalent of interfaces in other languages. But don't worry, you will have enough information in README. And to pass this task, you have to pass the tests or your implementation. And basically, you can test it very easily with the cargo test command that will automatically run the tests. So if you will pass the tests, then you should be all right. And as always, if you will have any questions, don't hesitate to ask on Discord. So thank you very much for today. I hope you enjoyed today's lecture and have fun with the task, and see you next time. Goodbye.